Through this video tutorial, you're going to learn how to write a quadratic function in vertex form using the vertex and another ordered pair, both when it's written out and when it's on a graph. Let's start by just doing a quick review of vertex form of functions. So vertex form is f of x equals a times x minus h all to the power of 2 plus k. F of x, of course, is just another way of writing y, where it's written as a function of x. So we have our a value, which tells us if the quadratic's going to open up or down, if it's going to be vertically stretched or vertically compressed. It's that rate that it's multiplying by. Then you have h and k. And h and k are going to play a really large role today because h and k represent the actual vertex. As long as we know that point, then we can find a. So let's see what this would look like on an actual problem. So for our first problem, we're going to write the quadratic function that has a vertex of 2, -4, and passes through the point 4, 8. Since we know that this is the vertex, then we now have identified the h and k value for the vertex form. Another ordered pair, any other ordered pair, is a representation of any x and any y. So if we start with vertex form, and I'm going to call it y for us, so y equals a times x minus h squared plus k. Then I know the vertex is 2, -4. So what I want to do is I want to go over here and I want to plug in for h, I want to replace it with 2, and for k, I want to replace it with -4. Now 2 is positive, so the minus is already part of the formula for vertex form. And then the rest of it I'm not sure about. I really need to know the a value, but I don't have it. What I do have is another ordered pair, which is x and a y. So I'm going to take this x and y value and I'm going to substitute it in for the x and y in the problem. So y is 8. Still don't know a, but now I know x is 4, and so now I have this format here. 8 equals a times 4 minus 2 squared minus 4. Since a is the only variable now that I don't know, I should be able to solve for it. So I'm going to go about solving for a here. I'm going to simplify in my parentheses, eliminate the -4, and then see what I need to do from there. So 8 equals a times 2 squared minus 4. At this point, I'm going to go ahead and eliminate the -4 by adding. So now we have 12 equals a, and then 2 squared is 4, so a times 4. Now to get a by itself, I would divide by 4. So a in this problem should equal 3. So now since I already knew my vertex, and now I know a, I should be able to write the equation in vertex form. So I would have y equals, the a that I just found is 3, and then x minus 2 from that vertex squared minus 4. So remember 2 and -4 coming from the vertex here, and 3 is coming from a that we just solved for. And then so this would be vertex form. All right, let's try another one. So this time we're going to write the quadratic function that has a vertex of 5, 7. So this will be, remember this will be our h and our k values. So that's our vertex, and passes through the point 2, -29. So this will be a value of x and y. So if we start with vertex form, y equals a times x minus h squared plus k. Then y is going to be negative 29. X is going to be 2, and that's coming from that second ordered pair. Then we're going to have minus, h is going to be 5, and plus k is 7, so plus 7. And then that should be enough information for us to be able to solve for a, so that we can then write the final form. So if we solve this for a, we would have negative 29 equals a. This would be negative 3 squared plus 7. So I'm going to go ahead and square negative 3, which is 9. And then I'm also going to eliminate the 7. So I'm going to go ahead and subtract the 7. Negative 29 minus 7 is negative 36. And now we have a times 9. To get rid of the times 9, to make it a 1, I would divide by 9 on both sides. And so negative 4 equals a. So now we know the full equation in vertex form because we have a, we just found it, and we already had h and k from the vertex. So the full form would be y equals negative 4 times x minus 5 squared plus 7. So that's our vertex form. If you haven't paused to try one on your own, this would be a great chance to do that. So we have another quadratic function with a vertex of negative 6, 1, and it passes through the point negative 8, 3. So we're going to try to color code this. So I'm going to call the vertex, write it in pink, and the xy I will write in blue. So let's start with vertex form. Y equals a times x minus h squared plus k. And then y would be 3 equals a times x would be negative 8. And then this is going to be minus, and then our h is negative, so minus negative 6 squared plus 1. So when we go to simplify this, if it's minus a negative, that means it was translated to the left. We can just call it plus those. So negative 8 plus 6 plus 1. So if you wrote it this way to start with, that's perfectly fine. Now I'll simplify and solve for a. So we're going to have 3 equals a times negative 2 squared plus 1. I'm going to subtract my 1 from both sides. So 2 equals a times 4, and then divide by 4. So this would be 2 over 4, which would simplify to 1/2. So a equals 1/2. Now I can write my final form in vertex format. So y equals 1/2 times x plus 6 squared plus 1. Now this example may look different because it's on a graph, but it really isn't any different at all. It's just how you get the information is different. So we're going to have to identify the vertex ourselves. So the vertex is at 1, 3. And then we have 2 other plotted points for us, and we can choose either of those. So we could choose this one, which appears to be at 0, 5, or this one, which appears to be at 2, 5. It doesn't matter. We just have to have the vertex and one additional point. So I'm going to go ahead and use the 0, 5 one because I feel like that's what most of you would do as well. So starting with vertex form, so y equals a times x minus h squared plus k. I'm going to substitute in both the 0, 5 for the x and y, and 1, 3 for h and k. So y would be 5 equals a times x is 0 minus 1 squared plus 3. And that's just coming again from the vertex. And then I'll simplify. So we will have 5 equals a times negative 1 squared plus 3. So I'll subtract 3 on both sides. So 2 equals a times positive 1, because negative 1 squared is positive 1. And then I really don't have to divide by 1. I could divide by 1. It doesn't really serve a purpose because the idea is to get to 1. So this one, a is 2. That means our final vertex form is going to be y equals 2 for a times x minus 1 squared plus 3, using the vertex of 1, 3. And that is how you write vertex form equations for quadratics using a point and the vertex.